In this video, we're going to talk about periodic trends, and those are trends of different properties of atoms of elements as we go across and down the periodic table. So the first thing we need to talk about is shielding. And shielding, what happens is when you have an atom that has the positive nucleus and it's got the negative electrons around the outside, the electrons that are between those outer electrons and the nucleus, they are repelling each other and pushing those outer electrons away, even though the electron itself is attracted to the nucleus. And let me show you a picture. You can see here, you've got the nucleus, Z. You can see it in red. And then you've got those outer electrons right here that are attracted, because remember, the nucleus is positive, the electron is negative. So those blue lines show that there's attraction there between the outer electrons and the nucleus. And then the electrons that are between the nucleus and the outer electrons, those are actually repelling those outer electrons a little bit. And so what happens is those outer electrons don't have that same attraction to the nucleus. So what happens is those electrons on the outside, they're attracted to the nucleus, but they don't feel as strongly attracted because they're also being repelled at the same time by the electrons that are between the outside electrons and the nucleus. If you think about going to a concert, if you've ever been to a big concert, if you're in the front row, there's nothing between you and the band. So you can see everything, you can hear everything, it's really awesome. If you're like me, you end up sitting in the cheap seats. And so you've got people that are between you and the band, and so when they're standing up or they're yelling and screaming, you don't get the same effect, you don't get the same sound, you can't see as well. So it's that kind of thing. Whatever is between you and the band is causing shielding. It's the same thing with those outermost electrons and the nucleus. All of those electrons that are between are kind of preventing them from being as attracted. All right, let's talk about atomic radius. You guys know what a radius is. It's for things like circles and spheres. It's how we determine their size. So obviously the atomic radius is just the radius of an atom. And so there are several different methods of determining the radius. Usually what scientists do is measure the distance between two atoms that are sitting next to each other. And you can see, if you look, you've got two atoms and you can see their nuclei. If you measure that distance between them and cut that in half, that is a way to measure atomic radius. But the way we think of measuring radius is from the center of something circular to the outside. You can also measure it that way. So there are a couple of different ways, and so sometimes when you look up an atomic radius, you might find more than one value depending on the site that you look at. And you might see that one's a non-bonding atomic radius, which is the measurement to the edge. One is a bonding radius, which is the measurement from nucleus to nucleus. The next thing we need to talk about is ionization energy. So hopefully you remember from Unit 2 that an ion is an atom that has an imbalance of charge. So it either has more electrons than protons or fewer electrons than protons. Remember that atoms can only gain and lose electrons. And so what ionization energy is the amount of energy it takes to take one electron away from an atom. And if you think about that, if you remove a negative electron, think about the charge. Hopefully what you're thinking is that's the process of making a positive ion. You've removed one negative electron, so that makes it more positive. The atom has more protons than electrons. And you can see in this example down here with potassium that if you remove an electron from potassium, it forms a positive ion because it has more protons than electrons. The last one we need to talk about is electronegativity. And the definition of electronegativity is the ability of an atom that is in a compound. That's really key. So underline it, highlight it, whatever you like to do. And what it does is when it's in a compound, you have two atoms next to each other. One atom that has a higher electronegativity is next to another atom. If the electronegativity is not the same, the atom that has a higher electronegativity will attract the electrons from the other atom to itself. So elements and compounds tend to spend more time around atoms that have higher electronegativities. They don't go there and stay, they just tend to be more attracted. They don't go there and stay, they just tend to be more attracted to the atom that has that higher electronegativity. And what can happen is if you've got more electrons, think about it, it's going to be more negative in that part of the compound because those negatively charged electrons are kind of hanging around on that end of the compound. And so it's going to form a little partial negative charge. And we'll start getting into this a little more in the next couple of units. That's it. We're just talking about the definitions. We'll start looking at the trends in the next video. See me if you have questions.